Hello everyone, and welcome back to Tech with Enki. In today's video, we're going to take the next step in our data analysis journey and dive into Pandas, which is a powerful library for working with structured data in Python. For this video, we're going to go through setting up our environment, then we're going to look at Pandas data structures, specifically Pandas series and Pandas data frames, and at the end of our video, we're going to have a final example. In these series and data frames, we're going to look at a few operations that we can carry out with both. And with this final example, we're going to work with real-world weather data, and we're going to explore how to load, clean, and analyze this data with Pandas. And by the end of this video, my aim is to get you familiar with handling datasets with Pandas. So get ready and let's dive right into it. So like we saw in our previous video on numpy, the first thing we need to do is to set up our environment right. So if you do not have Pandas installed, you can do so with a simple pip command, pip install pandas, and import pandas as PD, which is a general standard for Python programmers. The next thing we're going to look at are Pandas data structures. First, we're going to talk about Pandas series, and then we're going to talk about data frames. Talking about series, the first thing we need to do is to see how to create this Pandas series. But before we go ahead to create our first series, I want you to keep in mind that you can look at Pandas series just like numpy 1D arrays. The main difference is just in the data types, but the behavior is quite similar. We're going to leave a comment here, creating a Pandas series, and we're going to call this series S1. To create this series, we're going to use a Pandas method called series. And all we need to do now is to pass a list to this. So I'm just going to pass a list with some random values. Let's say 4, 8, let's say 12, and let's put in a negative value, let's say -3. So if I run this code cell, we have a problem here. PD is not defined. Oh, I forgot to run this first code cell. So let me run this. And now let me come back and run this code cell, and that did work successfully. So if I display S1 here, we have our series. And keep in mind that Pandas data structures will generally appear like tables when you display them with Jupyter notebooks, be it the series or the data frames. And there's one more thing I want us to look at under this Pandas series, which are series attributes. And there are two attributes that are important, the index and the values. When you look at this table, you see that what we have here on the right side are called values. So these are the values of this series. And on the left side here, these are the indexes. So think about this. When we usually work with like lists or arrays, we always had indexes that we could use to like select values or to like slice values. But with Pandas, when we display our object, we're able to see the indices by the side, and so we don't need to memorize them. This is also useful because we can actually play a little bit with these indices and modify them. They must not be like 0, 1, 2, 3 like we've always known. We could actually change this and have them have values like stars. Like you think about dictionaries, when like the index or the key of a dictionary could have like different data types. This is almost the same thing also with Pandas series or data frames. So the two attributes we're talking about here are the indices and the values. And we can display them if we decide to print in brackets, let's say s1 dot, let me correct this, uppercase s1 dot index. If I display that, we have our indexes here. This tells us that we have a range index object that starts from 0 and ends at 4 with a step of 1. So 0 plus 1, 1, and then plus 1, 2, until you get to these 3 here. And we can also display our values. If I copy and paste this, instead of printing index here, I can print values. And if I run this code cell, we also have our values here from 4, 8, 12, and 13. And attributes aside, the next thing I want us to look at is how to retrieve values. Let me put a comment here and retrieve values. I'm going to add a code cell here. And remember, we said we could treat Pandas series just like 1D arrays with numpy. And so thinking about this, our syntax to retrieve values is going to be pretty much the same thing. So let's give it a try And let's say we want this value 8 right here, so the second value here. So we're going to print, and in the print box we're going to call S1, and just like the numpy we're going to use square brackets, and we're going to pass the index 1 for the second position here. And if I run that, we have our value 8. And there are a number of things we could do with this. We could also obtain slices. So if I copy this and paste it here, and let's say we want from 8 to -3. So instead of just selecting one, we're going to select a slice. So we're going to use a colon and then leave it like that to say we want to get the values from 1 to the end. And if I run that, we have 8 here, and then we have this. Let us add a new line here to be able to differentiate this. So I'm going to put in quotes, I'm going to add a \n here to add a new line, and I'm just going to put one here as well. I'm going to put a comma first and then in quotes a \n to add a new line. And now we can see clearly we have 8 here, and then we have our slice from 1 to 3. And one more cool feature is that we can actually choose which indices we want to obtain. Let's say we wanted just the first and the third elements here. What we could do would look something like this. Let me just copy this and paste it here. And inside these square brackets here, I'm going to introduce another set of square brackets, and I'm going to pass the indices 1 and 3. So if I run this code cell now, we can see that we're able to obtain the first element here, which is 8. We're able to obtain our slice here from 1 to 3. And in this last output, we're able to obtain the first and third indexes alone. And that's pretty much how you retrieve values from Pandas series. We can also talk about mathematical operations, but remember I told you all of this is just like numpy 1D arrays, and so the syntax, the outputs, everything is just going to be the same. If we try to do something like an S1 plus S2, we're going to do like element-wise additions and stuff like that. So I think that is worth keeping. But before we move to Pandas data frames, I want you to note that these indices we're using here, as we have here, like 1, 2, 3 by default, the default indices we had here, we could actually modify these, and so they must not be numbers. They could actually be strings, booleans, or even floats. However, the syntax here for retrieving those values is not going to change. Let's say if we had like A, B, and C here, we're going to do the same thing here, like an S1A, S1A to the end, S1A, and C. Nothing is going to change. So that said, let's take a look at Pandas data frames. And the first thing I want us to do is to see how to create these data frames. There are a number of ways to create Pandas data frames, but one of the easiest ways is to use a dictionary. And this is our dictionary data. It has 3 keys: name, age, and city. Name contains a list of different names: Alice, Bob, Charlie, and Blake. Age has the ages of these different people, and city tells us the city in which these people live. And Pandas has a function to create data frames from these dictionaries. Let's create a variable here. We'll call it df, and we're going to set it to pd.dataframe, and we're going to pass the parameters to it. The first parameter will be our dictionary. We're going to set data, and another parameter I want to set is the index. Remember I told you with our Pandas series that our index must not be generic. That's from 0 to probably like 4, or have like just numerical values. But these indexes could actually be of different data types. So for this case, I want to use a different set of indices. I want to use stars, and I'm going to set this to A. I'm going to create a list. B. The length of this index just needs to match the length of the values in our dictionary. And as we can see, the length of our values in the dictionary is 4. So we just need an index with length of 4. So I'm going to pass another parameter here, that will be C. And the last one, we're going to put D. So if I run this code cell, let's say we want to display a data frame. So I'm going to run df, and I run that. As you can see, we have our data frame here looking like a table. We have our columns, name, age, and city, and our indices A, B, C, and D, and then our values. And pretty much this is how to create a data frame using a dictionary. And in our final example, I'm going to show you the most popular way of creating data frames. But before we get to that, I want to go through how to retrieve data from data frames. So starting with columns, what I want you to have in mind is that the syntax is the same like working with dictionaries. So picture these as like probably the keys of a dictionary, like these feature names we have here, like name, age, and city. Picture them like the keys of a dictionary, and then picture these like the values of our dictionary. So if we want these values, say Alice, then all we need to do is what? We'll call our data frame, df, which is our variable in this case, and in square brackets, we're going to pass what? Our key, or in this case, our feature, which will be name. And so if I run this code cell, and as you can see, we're able to extract all the elements in this column name. The same thing with age or city. If I change this and I just put age and I run that, I'm going to have all of these ages here. But one more thing that pandas can do that dictionaries cannot do is that we can select two of these at a time. So let's say we want name and age and not just age alone. Then we're going to call df, and in square brackets, I'm going to add another set of square brackets. So this is going to be the syntax anytime you're working with multiple columns. You need to pass them as a list. So the first element here, we're going to pass name. I'm going to put a comma here, and then the second element here, we're going to pass age. And so if I run this code cell, we're able to extract our names and ages. And this is one easy way to retrieve data from a data frame using our columns. But what about working with rows? Like if we want to use this indices here, A, B, C, or D. Let's try that and see what happens. Let's say we run df, and as a parameter we pass in A. And if I run that, we have an error. And with this, we know that we definitely cannot use our indices like this. But that's not going to be a problem because Pandas has methods to help us work with our indices. And if we want to use our indices instead of our column names, the function we need to use, or the Pandas method we need to use, is called loc. Well, there are two methods, loc and iloc, that can help us do this. And the syntax for this is not going to change a lot. All we need to do here is to put a dot and call the method, so dot loc. And if I run this, this should work. And as you can see, we're able to extract the row A, which contains name Alice, age 25, and the city New York. And we'll look back up here, you can confirm that we have Alice, age 25, city New York. And there's a lot more we can do with loc. Naturally, we could extract slices, and we can also add columns to specify the columns that we want, and not just every element in a row. Let's say we want to obtain slices. So let me add another code cell here. Let's leave a comment and let's say slices with loc. The syntax is not going to be very different. The first thing we need to do is to call our method loc. So df.loc, and the set of square brackets, we're going to pass, let's say we want to slice from A to C. We're going to pass A and then colon C. If I run that, then you can see we're able to extract elements from A to C. But if we do not want all these columns, we can specify, let's say we want just what, the name and the age. So if I copy this and I paste it here, we just need to add a comma here. Think about it like how we used to work with numpy arrays, like 2D arrays. We had like rows, comma, colon. This is pretty much the same thing. We specified our rows here, we have a comma, and now we're going to specify our columns. And remember, I just said each time we need to work with two or more columns, we need to pass them as a list. So I'm going to add another set of square brackets here, and I'm going to pass the name, comma, the age. And if I run this code cell, you see that we are able now to specify that we want just name and age and not city. And with this syntax, you can pretty much do anything you want with the method loc. But before we move forward, I want to show you another method that Pandas has to do almost the same thing, which is called iloc. Let me create another code cell here. And all you need to know is that the difference between iloc and loc is that loc is going to work with the index names, like in this case A, B, C. But iloc is going to work with numbers, that's indices, like integer locations. And so in the background, it's going to convert like this A here. The first element here will be a 0. The second element here will be 1, 3, 4, and so on and so forth. So let's say we want to do this same thing but using iloc. So let me copy this and I'm going to paste it here. But we're going to change this a little bit. Remember, A here is our first element, and so we're going to remove A and put 0. C here is at 1, 2, 3, the third element. and so I'm going to remove this, but I'm not going to put 2 because remember that when working with numbers, the upper bound is always excluded, and so if I want this same output like here, I'm going to put 3 instead. And for the colons, I'll have to remove all of these because we're no longer working with the colon names, and after the comma, all I need to put is 0 colon 2, and here modify this. It should not be lock, this should be iloc, and if I run this code cell, we can see we have the same output here. So the only difference is that iloc works with actual integers. So the actual integer positions behind this, like this should be 0, 1, 2, and so on and so forth, whereas loc works with the index names. And that said, there are a few basic operations I want us to look at with pandas. So I'm going to leave another markdown cell here for basic operations, and I'm going to add a few code blocks here or code cells. And the first thing I want to look at here is Boolean indexing. Let's say we want probably ages greater than 30. Remember we talked about this the last time. Let's leave a comment here, Boolean indexing, and the syntax is going to look pretty much the same like what we did with numpy. We're going to call our data frame df, and in a set of square brackets we need to specify a condition. Let's say we want people with ages greater than 30, then all we need to do is to call df in square brackets. We're working with the age, and we want ages greater than 30. So if I run that code cell, we see that Pandas is able to filter a data frame and extract any age greater than 30. And as we can see here, we have just one output for this person here, Charlie, who is aged 35. And there's a lot more we can do with Boolean indexing, and knowing this syntax is all you need to be able to implement a lot more. And Boolean indexing aside, let's say we want to add a new column to our data frame, because note that these data frames are mutable objects. So let's say we want to add a new column and want to call this column salaries, probably for the different salaries these users earn or these people earn in a year. All we need to do is same syntax like with a dictionary. We're going to call a data frame, and in a set of square brackets we're going to pass a new feature. We're going to call it salaries, and we need to set this to something. So I'm going to set this to a list. Remember that our columns here have 4 values. If I scroll back to the top, we have Alice, Bob, Charlie, and Blake. So probably we want to give salaries for all of these 4 users. So let's say the first user probably has like 70,000 in a year. The second person probably makes like, I don't know, 60,000. The other person probably makes like 100,000, and then the last person maybe makes like 300,000 in a year. So if I run that and then display df again, we see that we have a new column, salaries, with our input that we just passed to it. Now, looking at this data frame, there's something I want us to look at here. This input here called none. You can interpret none here as not a number, not a value. Pretty much none is like an empty space. So it's not rare that probably you're working with some data and then some users probably forgot to enter some input. Let's say you have like an Excel sheet and then there's some missing values. When you read this Excel sheet with pandas, those missing values are going to appear like none values. And in the world of like data analysis and data pre-processing, this is not a problem because there are so many ways that you can work with this. And pretty much there are 2 things you need to do. The first is to look at your dictionary to check if you have any none values. And then the second thing is to see how to deal with these values. You might decide probably to like, I don't know, delete maybe any rows with none values. Or you might decide maybe to like fill them with, I don't know, a specific value. And Python offers you a lot of possibilities on how to deal with these none values. But first things first, we need to identify the values. In this case, it was easy. We could just look at it because we have a very small data frame. But if we have like a data frame with like a lot of, I don't know, rows, maybe like 1,000, a million rows, we cannot just like scroll through to look for all those values. We're going to get confused. But Pandas has a function to help us identify these none values called isNA. So we're going to run df.isNA, open and close parentheses, and I'm going to add another method to this, which is sum, open and close parentheses. And if I run that, and with this, we're able to see that our column name has no empty values, our column age has 1 none value, our column city has no name values and salaries has no name values as well. So regardless, even if we have like a million columns, this is going to tell us each of those columns how many name values are present. And from there, we can decide on how to deal with these name values. And Pandas has a function to do that called field NA. So let me add another code cell here. I'm going to run df.fieldNA, and here now we can enter like what we want to fill these nine values with. For this case, we know that age here is empty, and just for this example, I'm just going to pass a default age here. I'm going to set this to 20, and I'm going to add another parameter here called inPlace. Well, the inPlace parameter just means that I want to modify the actual data frame and I don't want to return a new one. And so I'm going to set this to true. Note that a lot of Pandas functions will always have this inPlace parameter because these functions create new data frames. I think pretty much all of these functions. But then one thing to do is if you want to modify the same data frame, you need to set the inPlace parameter to true. And if I run this code cell and let's display df one more time, and we can see that we've given Blake an age of 20. For this case, I just guessed this up and the 20 came to my head, but in other cases, there might be something else you want to do with your NA values. You might want to delete it. You might want maybe to calculate the mean of ages and then set the age to that mean or something like that. But for this case alone, let's just set this to 20. And with this, I think we are ready to dive to our final example. So for this example, I downloaded a dataset online from Cargo under this account called Weather Data, and it has synthetic weather data generated for 10 different locations. We can see them here: New York, Chicago, San Antonio. And the data has the following features: location, the city where the data was simulated, date time, the date and time when the weather data was recorded, temperature in degrees Celsius, humidity, percentage, precipitations in millimeters, and the wind speed in kilometers per hour. And for our use case, all I did was just to download the dataset and apply a few functions to it to help us understand how to use Pandas a little bit better. And so in our case, we're going to see how to open this file and save its content in the data frame. We're going to preview the data. Then we're going to add another column to it or a few columns to it. We're going to see how to filter the data. Like in this case, we're going to filter specifically Houston's weather data from all the other cities. And then we're going to obtain like the hot days in Houston, another level of filtration. And then we're going to deal with missing data and finally sort our data before saving it in a new file. So let me come back up here and we're going to go back to the first thing we need to do, which is to open our file and save the content in a data frame. So when I downloaded the file weather_data.csv, I saved it in the same location where I'm working right now to make it easy to access it. So I'm going to call this data frame, let's say df1, and we're going to set this to pd.read_csv. So I want you to see that Pandas has a lot of functions to read different kind of files. You have like read CSV for CSV files, comma separated values. We also have like read Excel, we have read GBQR, HTML, JSON. So there are a lot of functions here to read different kind of files. But for this case, what we need to read is a CSV file. So I'm going to use that function and I'm going to pass our file to it, which is weather_data.csv. Then I'm going to run that code cell and that runs successfully, which means we are able to identify the file and open it and save its content in the variable df1. So looking at previewing the data, it's common practice that when we open files in Pandas, we need to display those files to at least see what we're working with. So one thing we can do is if we just display, let's say df1 and around this code cell, we see that we're able to see the first 5 values and the last 5 values. So from 0 to 4, and in this case, I don't know what this is up to this value here. Well, altogether we have a million rows and 6 columns for location, daytime, temperature, humidity, precipitation, and wind speed. But this might be too much. So Pandas comes with this function called head that helps us to display by default the first 5 values in our data frame. So if I run this code cell, we have our values from 0 to 4. However, you can modify this and say probably you want like the first 10 values, the first 20. You run that, it gives us the first 10. But by default, head is going to return the first 5. So this gives us an idea of what we're working with. And we can also run the describe function of pandas, df1.describe, which generates some useful statistics for our data. So when I run that df1.describe, well, what this does is it calculates the mean, standard deviation, minimum, maximum, count, 25th percentile, 50th, 75th for all of these columns present in our data frame. Well, for columns where it's possible to calculate all of these statistics, pretty much columns that have values, maybe integers or floats, and not columns like this one that have dates. And so with this, we are able to tell like the mean value for all the temperatures, the standard deviation for all the temperatures. This is in degrees Celsius, the minimum temperature, the maximum temperature, humidity, precipitation, and wind speed. And these are just some common functions used when we want to like preview your data and have probably an idea of maybe what you're working with. And the next thing I want us to do here is to add a new column to this data set. While considering we're working with US data, it makes sense to convert this temperature from Celsius to Fahrenheit. And these are some of the common things you always have to do with your data set. You always have to like look at it and see maybe how to like modify it, add a few columns, remove some columns, or pretty much carry out pre-processing. And the syntax to do this, like we saw before in the smaller data frame that we had, we just need to call our data frame, in this case df1, and then we're going to pass a new feature we want to include. In this case, that will be temperature, but not underscore C underscore F for Fahrenheit. And we know that to convert from degrees Celsius to Fahrenheit, we need to multiply by 9, divide by 5, and then add 32 to the value. So in this case, in parentheses, I'm going to extract all the temperatures we already have in degrees Celsius, which will be df in square brackets, temperatures underscore uppercase C. I hope I had that right. If not, that's going to return an error. But well, let's just go ahead and see. If not, we're going to come and correct it. Multiply by 9, we divide by 5, and then we add 32. So if I round this, we have an error. Temperature underscore C does not exist. Let me see. Oh, this should be an uppercase C and not a lowercase c. So let me remove this uppercase C. And now if I run this and let's display a df1.head, temperature underscore uppercase C still doesn't exist. Oh, this should be df1 and not df. We run this now and that worked. And as you can see, we've added another column, temperature underscore F. And carrying out simple operations like this, adding features to our data frame, is what's generally called feature engineering. And the next challenge we have is to filter Houston's weather data from the rest. Remember, we have different towns here: San Diego, Philadelphia, San Antonio, Houston, Dallas, and so on. And we want to filter Houston from the rest. Let's create a different variable here, because remember, these operations usually return new data frames. So in this variable, we want to save the new data frame we're going to extract. So Houston underscore weather, and we're going to set this to df1. In square brackets, we need to set a condition, which will be for df1 in bracket location. I think the location here is an uppercase L. I want to get any location which is equal to Houston. And if this works, we want to display the head of that. So Houston underscore data dot head to see the first 5 rows. So let me run that. And this ran successfully. So as you can see, we have all the locations here: Houston, 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 Houston. And having obtained these, we want to display, let's say, the hot days in Houston. Let's assume for this case that a hot day has a temperature greater than 80 degrees Fahrenheit. And so to do this, we're going to use Boolean indexing. We're going to call our data frame, which is Houston underscore weather. In a set of square brackets, we need to set our rule or our condition, which will be for Houston underscore data. We want to get the temperatures. So any temperature in degrees Fahrenheit which is greater than 80. And so if I run this, As we can see here, we are able to obtain a slice of the data in Houston_weather. And if we look at the temperatures underscore Fahrenheit here, we see that every temperature here is greater than 80. 101, 103, 99, 87. It's quite long, so we can't display all of it. But with this, you can already tell that what you did is okay. And naturally, we need to check for missing values and see if we need to handle any of these missing values. And remember the syntax to check for these missing values. We're going to call our data frame df1 dot. We're going to check if there are any NA values. Dot is NA, open and close parentheses, and then we're going to call the sum function. And if I run that, and this tells us that we have no empty spaces in our data set, so no need to deal with missing values. And just before we save our modified data frame, because remember, we've actually gone and modified this data frame, we've added a new feature to each, which is temperature underscore F. Just before we save this, I want us to look at how to sort values in our data frame. And the function I want us to use here is sort underscore values to deal with the values in our data frame. So I'm going to call df1.sort underscore values. You see that we have sort index and sort values, but for this example, I'm just going to use sort values. And let's say we want to sort by, we'll set the by parameter, and let's say we want to sort by locations. Because looking at the data, if we scroll back to the top here, and as we can see here, our location does not follow an alphabetical order, but we can change that just for this case, just to see how this thing works. And so if I sort by locations, and if I run this code cell, well, we have a locations key error. I think probably there's no S here. Let me run this again, and here the S was a problem. And as we can see, we start with Chicago and end with San Jose. So using this by parameter here, we could choose which feature we want to use to sort our data. It could be daytime, it could be temperature, anything. And we can reverse the order if we change the ascending parameter. It has a parameter called ascending. And if we set ascending to say false, and if I run this, we have the order has been reversed, and so we're moving from San Jose to Chicago. And last but not the least, we're going to save our modified data frame in a new file. The syntax to do this is quite easy. All we need to do is to call our data frame df1.to_CSV, because remember we're working with a CSV file here, and now we need to pass the new file name we want to save our data in. Let's just call this something easy. Let's say weather_data2.csv and set the index parameter to false. And if I run this, and if you look in our working directory, we should be able to see this file, weather_data2.csv. I want to believe I did my best to make everything clear and easy to understand, but if you have any questions, feel free to leave them in the comment section of this video, and I'll be more than pleased to answer you. If you enjoyed the video, do well to hit the like and subscribe buttons, and I look forward to seeing you in my upcoming videos. That said, have a good day.